Hello friends, today I'm going to continue with my works on equations of a parabola. Remember, a parabola is one of the concepts in a conic section, and a parabola is just the locus of a point which is equidistant from a fixed point, then from a given line known as the directrix. Okay, now let's assume that this is the fixed point, which is the focus, and this is that given line known as the directrix. Now this is the focus. So supposing you have the parabola like this. So supposing this is the parabola we are talking about. Y here is the focus of the parabola. Okay, let's say the focus is at the center here, the focus. So here is the focus. Now, this given line that is perpendicular to this directrix, okay, this given line is known as the axis of symmetry or the axis of the parabola. Okay, I remember the definition of a parabola. Supposing we have a point here, distance from this point to this line should be equidistant to this particular point. They are of equal distance from the definition of a parabola. Okay, now this particular point here is known as the vertex of the parabola, the vertex. So here is the vertex, while here is the focus of the parabola. Then this given line is known as the directrix, while this particular line here is known as the axis of symmetry or the axis of the parabola. Now let us take this particular point as the x-axis. Okay, let's take it as the x-axis, and this line here, which is the latus rectum, let's take it as the y-axis now, so that this particular point here is now our x-axis. Okay, now remember, by definition of a parabola, the distance from here to here and the distance from here to here remains the same. So assuming I call this point P and call this point Q and call this point R, for instance, you can now see that the distance PQ should be equal to the distance QR by definition of a parabola. So from P to Q should be the same distance from Q to R. Hence, we need to get the coordinates of P, Q, and R so that this distance can be got mathematically. Now, this particular point, let's assume that from here to here, that is, this is the origin, 0, 0 for both x and y. So let's assume that this distance from here to here is just A. If this distance from the origin to this particular point where I have my focus is A, it means that the coordinate of R is A, 0, because x is now A, while my y, this is at the origin, the height of y is 0 here. Now, coordinate of this particular point Q, if I trace down, I don't know the value of x here, and also I don't know the value of y here. So I can simply call it x, y as the coordinate of Q. Similarly, I have my P here, and this distance from here to here should also be equal to this distance from here to here, from definition of a parabola, equidistant from a fixed line, from a fixed point. So if here is from here to here is A, it means that from here to here is A also, but the A should be negative because it is in the negative x-axis. Hence, this particular point is negative A, while this particular point should be negative A also. So the coordinate of P will now be negative A for x. And what's the value? You should have the same value here as y. I don't know the value of y, I'll call it y also. So these coordinates are known. From these coordinates, let us now try to derive the equation of this parabola. So the equation of this parabola will now be, remember, distance between 2 points, PQ is equal to QR. And what is PQ? The formula is square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the formula. So let me get PQ first, after I will go for QR. Now for PQ, this is now x1, y1, while this is now x2, y2. We now put in the formula to now be square root of our x2 is x minus x1. x1 is negative a, so negative negative is positive, all squared, plus y2, my y2 is y, minus my y1 is y also, all squared. This will now give me x plus a all squared plus 0, because y minus y is 0 and 0 squared is still 0, so plus 0, no need. And this square root will cancel this square, so we are left with x plus a. X plus a is now the distance pq. Okay, so let us get qr, distance qr. Okay, so for qr, let me now call here x1, y1 and use it to get the distance qr. Okay, or rather this can be x2, this can be y2, so that here will now be x1, y1, since I'm talking about qr. So the same formula, I have square root of my x1 is x, okay, rather x2, my x2 is a, minus my x1 is x all squared, plus my x2, my y2 is 0, minus my y1 is just y, all squared. So this will give me square root of a minus x all squared plus y squared, because 0 minus y is just y, then when I square it I will get y squared. So I can now expand the bracket. So we continue from here. Hence the first one, we got x plus a as pq, so write x plus a as pq equals this as qr, equals square root of x minus, a minus x all squared plus y squared. That is what we have. Then square both sides so that this thing can go. If I square both sides, I will now have x plus a all squared, square cancel this, I'll have just a minus x all squared plus y squared. Okay, this is what I'm having. Now I'll collect like terms. Let me take this to come to this side, or rather I can open bracket if I want to open bracket. When I expand this bracket, I'll have x squared plus 2ax plus a squared equals, when I expand this bracket, I'll have a squared minus 2ax plus x squared, then plus this y squared that is here. This is the expansion of this bracket. You can still go and learn how to expand bracket. So I will collect like terms. This is now x squared is here. This x squared coming here becomes minus x squared. Then plus 2ax is here. Minus 2ax coming here is plus 2ax. Without wasting time, this a squared coming here will cancel out this a squared, so it has gone. We are now left with y squared here. Now x squared has cancelled out. We have 2ax plus 2ax, which is 4ax equals y squared. So we can now write that y squared is equal to 4ax, and this can give us the equation of a parabola.